This video will cover a solution guide to problem 62 from chapter 16. A uniform 165 Newton bar is supported horizontally by two identical wires A and B. A small 185 Newton cube of lead is placed 3/4 of the way from A to B. The wires are each 75 centimeters long and have a mass of 5.5 grams. If both of them are simultaneously plucked at the center, what is the frequency of the beats that they will produce when vibrating in their fundamental? To find the beat frequency, we first need to find the frequency of the waves in the individual wires. In the fundamental frequency, the wire only forms half of a wavelength as it vibrates. Knowing this, we can rewrite wavelength in terms of the actual length of the wires suspending the bar in the air. We also know that the speed of a wave on a string is equal to the square root of the tension in the string over the mass density. Using these definitions, we can rewrite the frequency of the waves traveling in the wires as 1/2 times the square root of the tension divided by the mass times the length of the wire. We were given the mass and the length of the wire, so we need to use the fact that the system is in equilibrium to find the tension in each wire. Because our system is in equilibrium, we know that the summation of forces and the summation of torques are both equal to 0. So from the summation of forces, we know that the sum of the upward acting forces are equal to the downward acting forces. Same idea applies to the torque. If we pick the pivot point to be about wire B, the torque from the forces trying to spin the bar clockwise are equal to the sum of the torque from the forces trying to spin the bar counterclockwise. Each force acting on the bar is perpendicular to the displacement from point B, so we have that the tension in wire A times the full length of the bar is equal to the weight of the bar, which is acting half of the length of the bar away from point B, and the weight of the block, which is acting a fourth of the length of the bar from point B. Rearranging our torque equation to solve for the tension in wire A, we find that the tension in A is 128.75 newtons. Plugging this value back into our equation for the summation of forces and rearranging for the tension in B, we find its value to be 221.25 newtons. We now have everything we need to find the frequency of the waves in each of the wires. The beat frequency is simply equal to the difference between the frequency in wire B and the frequency in wire A. Plugging the definitions for these frequencies into our beat frequency equation and the values we were given and the tensions we just solved for, we find that the beat frequency created by the vibrations in the two wires would be equal to 27.53 Hz.